March 24, 1945. The Rhine River crossing at Vasil. German defenders watched American forces mass on Wehrmacht. Officer knew the principles the Western Bank with grim satisfaction. Every of river defense. Concentrate artillery on obvious crossing points. Position machine guns to enfilade the kill zones. Wait for assault boats struggling against the current, then open fire. The mathematics of defensive warfare favored the side holding the far shore. What those defenders couldn't have known was that 2,000 vehicles were about to drive straight into the river, without boats, without bridges, without ferries. Vehicles that would transform from trucks into watercraft in seconds, carrying entire infantry companies across the Rhine faster than any assault boat ever could. The DUKW, pronounced duck, was about to render centuries of river defense doctrine obsolete in a single morning. The story begins 2 years earlier in a basement office at the National Defense Research Committee. Rod Stevens Jr., yacht designer and naval architect, stared at casualty reports from Operation Husky, the invasion of Sicily in July 1943. The numbers told a brutal story. Landing craft delivered troops and vehicles to beaches successfully, but supplies piled up uselessly at the waterline. Conventional trucks couldn't navigate through surf to reach the beach. Everything had to be unloaded by hand, carried above the tide line, then reloaded onto trucks. The process created catastrophic bottlenecks. Entire divisions sat immobilized while ammunition, food, and fuel accumulated just offshore. Stevens had been designing racing yachts before the war. He understood water. He also understood the fundamental problem. The military treated water and land as separate domains requiring separate vehicles. Boats moved supplies to shore. Trucks moved supplies inland. The transition between domains created vulnerability. What if one vehicle could do both? Not a boat that could drive a little, but a truck that could actually swim. The concept seems simple until you examine the engineering challenges. Trucks are heavy boxes designed to roll on wheels. Boats are shaped hulls designed to displace water efficiently. Combining both requirements meant satisfying contradictory physics. A truck hull would be a terrible boat. A boat hull would be a terrible truck. But Stevens had an advantage. The GMCC CKW 2.5-ton cargo truck already existed in vast quantities. Its six-wheel drive system, powerful engine, and robust frame made it the workhorse of American logistics. If that proven platform could be made amphibious, the military would gain capability without redesigning logistics from scratch. Stevens partnered with Dennis Polliston, a sailor and engineer, along with Frank Spire from yacht builders Sparkman and Stevens. Together they began sketching what would become Military Designation DUKW. The name itself was GM's model nomenclature. D indicated 1942 design year. U meant utility amphibian. K signified all-wheel drive. W designated dual rear axles. The prototype emerged in April 1942, a standard GMC truck chassis wrapped in a watertight boat hull. The hull extended from bumper to tailgate, rising high enough to provide freeboard in rough water. A propeller mounted at the rear connected to the transfer case through a power takeoff. On land, power went to the wheels. In water, the driver engaged the propeller, while the wheels simply trailed. The transition took seconds. Drive into the water, engage the propeller, keep moving. No stopping, no transferring, no bottleneck. Military observers watched the first demonstration with polite skepticism. Vehicles had been made amphibious before. The results were universally disappointing. Marginal boats, marginal trucks, compromises that did nothing well. The DUKW would be different, Stevens insisted, because it prioritized the truck function. This wasn't a boat pretending to be a truck. This was a truck that happened to float. The difference mattered. On June 6, 1942, a Coast Guard patrol boat sank off Provincetown, Massachusetts. Seas were running 8 feet. conventional rescue boats struggled in the surf. Someone suggested testing the DUKW prototype. Stevens and his team drove the vehicle straight into the Atlantic through waves that would have swamped normal trucks instantly. The DUKW rode over the surf, reached the survivors, loaded 7 men aboard, and drove back through the breakers to the beach. The Coast Guard commandant sent an immediate message to Washington. This vehicle works. Build thousands. Production began at Yellow Truck and Coach Manufacturing in Pontiac, Michigan. The first DUKWs rolled off assembly lines in January 1943. Each vehicle measured 31 feet long, 8 feet wide, and weighed 14,000 pounds empty. The GMC 269 cubic inch inline 6-cylinder engine produced 91 horsepower. Not impressive by modern standards, but adequate for both domains. On land, the DUKW could carry 5,000 pounds of cargo or 25 fully equipped soldiers at speeds up to 50 miles per hour. In water, that same load moved at 6 miles per hour, faster than most assault boats of the period. The whole design incorporated subtle genius. Rather than a simple rectangular box, the bottom featured a gentle V shape that helped the vehicle rise over waves instead of ploughing through them. Spray rails along the sides deflected water away from the cargo bed. A bilge pump handled any water that did enter. The entire system was engineered for reliability over elegance. Operation Husky in July 1943 provided the combat debut. DUKWS swam ashore through Mediterranean surf, carrying artillery pieces that would have taken hours to land conventionally. Crews drove straight from landing ships to firing positions inland without stopping. German defenders had prepared for a traditional amphibious assault. They'd zeroed their artillery on beach supply dumps that never formed because DUKWs eliminated the beach logistics phase entirely. The vehicles drove supplies directly to forward positions. Casualty reports from Sicily showed something remarkable. Beach congestion, the primary cause of delays and losses in previous amphibious operations, had essentially vanished wherever DUKWs operated in sufficient numbers. But Sicily was a proof of concept. The Rhine crossings would be the ultimate test. By March 1945, Allied forces had fought across France and Belgium to reach Germany's final natural barrier. The Rhine River, between 400 and 1,300 feet wide, depending on location, represented the last defendable line before the German industrial heartland. Wehrmacht doctrine emphasized river defense. Every officer studied Frederick the Great's teachings on using rivers as force multipliers. Position your forces on the far bank. Destroy all bridges. Wait for the enemy to attempt crossing in vulnerable assault boats. Concentrate fire during their most exposed moment. The system had worked for centuries. German engineers had destroyed every bridge across the Rhine except one. The Ludendorff Bridge at Remagen had been captured intact on March 7th, but it collapsed 10 days later from damage and overuse. By late March, the Rhine remained unfordable from Switzerland to the North Sea. Conventional military wisdom said crossing would require massive artillery preparation, smoke screens, assault boats, engineering battalions, building pontoon bridges, and accepting heavy casualties during the vulnerable crossing phase. The Allies prepared accordingly. Operation Plunder, the crossing at Vasil, involved more firepower than D-Day. Over 3,000 artillery pieces, carpet bombing by RAF heavies, airborne drops, every trick in the doctrine manual. What German defenders didn't know was that the Americans had 2,000 DUKWs positioned along the western bank. These vehicles would rewrite the crossing operation completely. March 23rd, 1945, 9 p.m. Artillery opened fire across the entire front. German positions disappeared under the largest bombardment since Verdun. The barrage was real, but it was also misdirection. While German defenders huddled in bunkers, 300 DUKWs loaded with infantry from the 30th Infantry Division lined up along the riverbank north of Vasil. At 2 a.m. on March 24th, the DUKWs simply drove into the Rhine. No assault boats, no waiting for engineers. The vehicles entered the water, engaged their propellers, and motored across. Current pushed them downstream slightly, but drivers compensated using techniques learned in training. 6 minutes after entering the water, the first DUKWS ground ashore on the eastern bank. Troops jumped out already 50 yards inland from the waterline. German defenders, expecting assault boats in predictable crossing zones, found American infantry arriving from unexpected directions at unexpected speeds. The DUKW's psychological impact proved as devastating as its tactical utility. German machine gunners trained to target slow assault boats struggled to track vehicles that moved with purpose rather than drifting with current. Artillery observers couldn't establish firing solutions because targets didn't linger in kill zones. By the time German crews adjusted their aim, DUKWs had already crossed and were unloading inland. Doctrine said river crossings took hours and cost thousands of casualties. This crossing took minutes, and the defenders barely had time to respond. By dawn, 12 entire infantry battalions had crossed the Rhine in DUKWs. No pontoon bridges yet existed. No ferries operated. Just trucks that swam, carrying the American army into Germany faster than defensive doctrine could aid her. The engineering behind this capability deserves examination. A standard truck becomes a death trap in water. Steel doesn't float. But the DUKW hull displaced enough water to support the vehicle's weight plus cargo. Archimedes' principle in action. The hull volume below the waterline pushed aside 18,000 pounds of water, creating sufficient buoyancy to float 14,000 pounds of vehicle plus 5,000 pounds of cargo. The math worked. Barely. Overload a DUKW and it sank. Damaged the hull and it sank. The margin for error was thin. Yet these vehicles operated in combat conditions, often overloaded, occasionally damaged, and almost never sank. The robust construction that made them heavy trucks also made them survivable boats. Propulsion presented another challenge. The single propeller at the stern provided adequate thrust, but made steering in water tricky. DUKWs didn't have rudders. Steering came from the front wheels, which still turned even while submerged. This created a weird hybrid steering system. Turn, the wheel, and the front wheels angled, which changed how water flowed past the hull, which altered the vehicle's direction slightly. It wasn't precise. Drivers learned to anticipate and oversteer. But it worked well enough for crossing rivers. The power takeoff connecting the propeller to the transfer case could be engaged or disengaged with a lever. On land, the propeller just spun freely in the air, causing no problems. In water, disengage the propeller, and the DUKW became a very poor boat drifting with the current. The transition between modes had to become instinctive. Approach water, slow down, engage propeller, drive in, maintain momentum, drive out, disengage propeller, accelerate. The entire sequence took skilled drivers about 15 seconds. Training programs emphasized the psychological adjustment as much as the mechanical operation. Driving a truck into a river violated every instinct. Soldiers had to trust the vehicle wouldn't sink. Early training sessions featured instructors riding along, calmly smoking cigarettes as DUKWS entered water. The message was clear. This is routine. Don't panic. The vehicles became so reliable that drivers grew casual about water crossings. After the Rhine, engineers used DUKWs to cross every river in Germany. The Weser, the Ems, the Elbe. Conventional forces built bridges, waited for engineers, and followed doctrine. DUKW units just drove across. German attempts to counter the vehicles proved ineffective. Artillery couldn't track them. Machine guns barely scratched the hull. Mines designed for boats didn't work against vehicles that could drive around obstacles. Mines designed for trucks didn't work against vehicles that swam. The DUKW existed in a tactical grey zone that defensive doctrine hadn't anticipated. Some German units tried stringing cables across rivers to snag propellers. This worked occasionally, but DUKWs could reverse, back off the cable, and try a different crossing point. The flexibility was maddening for defenders. Block one crossing site and attackers simply moved 200 yards and tried again. Production statistics reveal American industrial capacity at peak efficiency. From January 1943 to August 1945, factories built 21,147 DUKWs. That's 8.3 vehicles per day for 30 months straight. Each DUKW required 2,000 pounds of steel, a complete GMC truck chassis, a custom welded hull, propeller, bilge pump, and specialized controls. Building them at this pace while simultaneously producing tanks, aircraft, ships, and every other weapon system demonstrated manufacturing coordination that Germany couldn't match. The vehicles cost approximately $7,000 each in 1943 dollars. Expensive compared to trucks, cheap compared to specialized landing craft. The return on investment was absurd. A single DUKW could deliver supplies from ship to frontline in one trip that would have required a landing craft, a crane, a truck, and multiple handling steps under conventional logistics. Post-war analysis by the US Army identified the DUKW as one of the war's most significant technical achievements. Not because it was sophisticated. The engineering was straightforward. But because it solved a problem that doctrine said required accepting casualties and delays. River crossings were supposed to be hard. Amphibious logistics were supposed to be complicated. The DUKW just ignored those assumptions and drove straight through the difficulty. General Eisenhower included the DUKW in his list of equipment that won the war, alongside the C-47 transport, the Jeep, and the atomic bomb. High praise for a truck that learned to swim. The vehicle served long after Germany surrendered. Korean War, Vietnam, civilian rescue operations, tourist attractions in several cities. Some DUKWs remained in service into the 1990s, 5 decades after their design. Modern militaries use descendants of the concept. The LARC, the Marines AAV, various Soviet and Chinese amphibious vehicles, all trace lineage back to Rod Stevens sketching a boat-shaped truck hull in 1942. The principle proved universal. Eliminate the transition between domains and you eliminate vulnerability during transition. But the real revolution happened on the Rhine in March 1945. German defenders watched their carefully prepared defences become irrelevant in real time. Doctrine said river crossings required pontoon bridges, which took hours to build and became priority targets for artillery. The Americans just drove across. Doctrine said supply lines were vulnerable during amphibious operations. The Americans drove supplies from ships to foxholes without stopping. Doctrine said attackers needed numerical superiority to overcome defensive advantages at river barriers. The Americans crossed with equal numbers and still won because their vehicles operated in dimensions defenders couldn't contest effectively. Military historians debate which weapons were most decisive in World War II. The debate usually focuses on tanks, aircraft, and naval vessels. Combat systems designed to destroy enemy combat systems. Yet logistics determines who can actually fight. The DUKW wasn't designed to kill anyone. It was designed to deliver the supplies and troops that would do the killing. In that role, it changed warfare as fundamentally as any weapon system. The ability to ignore terrain obstacles, to treat water as merely inconvenient rather than impassable, gave American forces operational flexibility that German defenders couldn't predict or counter. They prepared for the war they understood. They got a war where trucks drove across rivers, and nothing in their doctrine had prepared them for that simple, devastating capability. That's why 2,000 amphibious trucks mattered more than anyone expected. They didn't win through firepower. They won by making the battlefield itself irrelevant.